Hey everyone, I am Janapati Srinu. Who are watching first time my video, subscribe my channel and share to your friends. In previous video, we discussed about TS CPGET 2021 chemistry question paper of part 1 and part 2 video. In this video, I am going to discussing about part 3 video, that is from question 67 onwards. Question number 67. What is that? Precursor used to synthesize alanine in Strecker synthesis, right? In Strecker synthesis to prepare the alanine. So first you should know the what is alanine, right? Alanine means CH3 C. Generally I am going to write common skeleton for amino acid. R here hydrogen, here NH2 group and here COOH group. So in place of R, right? In place of R, if I will take hydrogen, that is glycine. If I will take hydrogen, that is glycine. If you want alanine, in place of R, you should just take the CH3 group. That is alanine structure. Alanine structure. So first you should know the Strecker synthesis. Generally Strecker synthesis is used to prepare the amino acids, right? Amino acids, except glycine, we can prepare the remaining amino acids. So first, what is Strecker synthesis? Strecker's synthesis. First I will write general reaction. First if I will take NH4Cl plus sodium cyanide, NaCl, sodium cyanide, so it gives the NH4Cl, ammonium cyanide plus sodium chloride. From this ammonium cyanide, upon heating, it forms the ammonia gas plus HCl, ammonia plus HCl. In this Strecker synthesis, we will use the ammonia and HCl. So sometimes if they will give NH4Cl in thermal condition also, we can take it is as a Strecker synthesis. So next, so general reaction is, if I will take R, C double bond OH, generally aldehydes, right? Aldehydes upon reaction with HCl, cyanides, right? Upon reaction with HCl, what happens? This cyanide Cl minus is going to attack here. It forms O minus and this H. It forms the R, C. This is what? OH. This is H is as it is. This is what? Cyanide. This cyanide upon, so generally this with ammonia. So what happens? It forms the, in place of OH, generally directly I am writing, not writing the mechanism. Just I am writing the mechanism only. I am writing the just what are the main products. So CH2, here you will get in place of OH, that is replaced with CH2. Then this is H. So next, upon hydrolysis, H3O plus. So what happens? In place of cyanides, we will get the acids. We will get the acids. That is what? COOH. This is what? H. This is what? Cl. So what is the question they asked? They asked the alanine preparation. What are the precursors used, right? What are the precursors used? So if I will take ethanol. Ethanol means, so generally ethanol means CH3. Eth means 2 carbon. CH3, Al means aldehyde group. So CH3, C double bond OH. This is 2 carbons are there, eth, and Al is ethanol. If OL is there, you can write ethanol. Ethanol is alcohol, like ethanol is CH3, CH2OH. Ethanol, like ethanol is different and ethanol is different. Nal means aldehyde group. So ethanol means in place of R, if I will take CH3, so this is nothing but ethanol. Ethanol. Al, aldehyde group, ethanol, 2 carbons. Same I am taking ethanol. So in presence of this one, we will get in place of R, just write CH3. Here also CH3 you should write. Here CH3. Initially I told you now already. What is that? Here, sorry. Yes, in place of Cn just write. What is there? NH2. So same like, similarly, first I write the structure of alanine. What is the alanine structure? This is used from the Strecker synthesis. The alanine is prepared from the Strecker synthesis. Very simple reaction. Sometimes they will ask the question, which of the following amino acid cannot be prepared from the Strecker synthesis? So that is what? Glycine. Next, question number 68. What is that? A compound in ozenolysis reaction gives formaldehyde, malondialdehyde and acetone. The structure of the compound. The structure of the compound. First I am writing the first option. This is option number 1. This is second option I am writing. Right. So they asked what are the products upon ozonolysis. We will get the formaldehyde, malonaldehyde and acetone, right? We are getting the 3 products. So first I will write. So first, whenever you are writing one trick for ozonolysis upon alkenes, so you should write, whenever you are cleaving the double bond, you should write O here, O here. Again you should write O here, O here. Same pattern you use, O, 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 O. Like now I will write, this is what? Double bond is there, double bond O is there. So nothing is there means CH2. CH2 means you can write H, H. Plus, here again O, that is what? O double bond. This is carbon is as it is, this carbon is as it is, this is again we are getting double bond O. Plus, what is the next one? O double bond, this one. This is formaldehyde, already we know that formaldehyde. This is what? Dialdehyde, but it is succin dialdehyde. Succin dialdehyde. I will show you after this. What is the difference between malone and succin, adipic, glutamic? I will discuss. So this is what? Double bond. O is as it is. Then nothing is there means hydrogen is there. So the second one is what? O. Whenever O is there, double bond. This is what? 1. This we will get the double bond. And next is acetone. O double bond acetone. So this is formaldehyde. This is what? Malone aldehyde. This you can, nothing is there means CHO. CHO, CHO. Dialdehyde. Malone means only one carbon. Malone dialdehyde, then acetone. So 3 products. Second option is correct. So one trick I will tell you regarding this malonic acid, succinic acid. All these are aldehydes, but if you want acids, right? Like if it is CH2, one CH2 is there, COOH. This is COOH. This is called malonic acid. Malonic acid. Same if you want to write 2 carbons like CH2 taken 2 times means we can also write like this. CH2, CH2, COOH, COOH. Like previously only like in place of COOH we got the aldehyde, that is malone dialdehyde, but it is malone dicarboxylic acid. You can say this is 2 are there, you can write that time succinic acid. Succinic acid. If 2 in place of acid, succinaldehyde, succin dialdehyde. Malonic acid, succinic acid. Malonic acid, succinic acid, adipic acid. If 3 is there, adipic acid. 4 is there, glutamic acid. Like this. Like this you will get malonic acid, succinic acid, adipic acid, glutamic acid. Like this you will get. Oh my, such good apples. So nothing is there. For example, directly if nothing is there, COH, COH. If 1 is there, CH2, COH, COH. So if you want to remember like shortcut, this is what? Oxalic acid, oxalic acid. This is what? Malonic acid. So simply in place of starting word O, oxalic acid, my, malonic acid, oh my, such, succinic acid, yes, oh my, such good, glutamic acid, adipic acid. Like this, oh my, such good, apples are so sweet. Like this, we will use generally those shortcuts. Next, question number 69. 69, right? What is that? The product obtained when 2-nitropropane treated with NaOH followed by H2SO4 is. So this is nothing but Neff reaction only. Neff reaction. What is that? 2-nitropropane, CH3. This is C. This is propane. Generally this is the propane. In place of this you should write NO2. Here hydrogen. 2-nitropropane. 1, 2, 3. 2-nitropropane in presence of NaOH and H2SO4. You will get CH3, C, CH3, heat acetone you will get, acetone, like acetone you will get. So in place of NO2 you will get upon OH, generally you will get the mechanism like whenever this NO2 is there now, this NO2 is like this, N double bond O, this is O minus. Upon rearrangement you will get double bond here, O minus here, again you will get CH3, C, N, O minus, H is there, OH, here O minus is as it is, this double bond, this is you will get CH3. So from this you will get the, upon H2SO4 you will get the half nitrous oxide, N2O gas, and the product is acetone. This is Neff reaction. Neff reaction. Next, question number 70. Option 3 is correct for previous one. Question number 70. What is that? The product obtained when propanoic acid react with thionyl chloride, diazomethane, silver oxide and water is. This is called the Arndt-Oersted reaction. Arndt-Oersted reaction. Named reaction only. Oersted reaction. What is that? So in what they given? Propanoic acid. Propanoic acid means CH3, CH2, C double bond OH. This is propanoic acid. So upon first SOCl2, thionyl chloride, we will get the, in place of OH, so SO2 gas is released and HCl gas is released. You will get the CH3, CH2, then C double bond OCl. So acid chlorides we will get, upon SOCl2 byproducts are SO2 and HCl, it gets released. So from this if you add diazomethane, CH2 minus N2, CH2 minus N2, this CH2 is going to attack here. After some rearrangements like Wolff rearrangement also takes place in this. So after silver oxide and tautomerism formation you will get directly one. Whenever Arndt-Oersted reaction is, one simple shortcut, if you will take diazomethane, diazomethane means only one carbon is there, that carbon is simply inserted here, you will get CH3, CH2, CH2, C double bond OH. This is as it is. So you can write, upon acid you will get, upon here Cl is there, that upon hydrolysis you will get OH like this, one extra carbon, 1, 2, 3, 4, butanoic acid. So in place of diazomethane, sometime they will give, for example, like C2H5N2, C2H5 minus N2, you will get 2 carbons extra. This is one short trick for Arndt-Oersted reaction. Very simple, named reaction only. Next, question number 71. What is that? Which of the following is a peroxide, right? Peroxide means you should know the difference first. What is that? First you should know the oxide, peroxide and superoxide. Right? Oxide is O minus 2 is called the oxide. So generally like we will use the O minus 2. So then O2 minus 2 is this is the oxide. This is what? Superoxide. This is what? Peroxide. Peroxide. Then O2 minus is superoxide. Superoxide. So best example for O2 minus 2 peroxide is what? We know that H2O2 is a peroxide. H2O2 is a hydrogen peroxide. In this you will get what? 2H plus plus O2 minus 2. This is what? Hydrogen peroxide. So O2 minus 2 is called the peroxide. So O2 minus is called the superoxide. If you observe the options, so platinum O2. Platinum O2. In this oxygen is, if you whenever you are writing the oxidation state, how you will calculate the metal oxidation state? Platinum is X plus 2 into O is there means O is minus 2. You will get 0. X is equal to plus 4. So minus 4 comes this side, plus 4, platinum plus 4. Platinum plus 4 you will get. So for here, second option is barium O2. Barium is what? Which group? Barium is a second group, like lithium, that is what? Beryllium, magnesium, calcium, strontium, barium, radium. Barium. So barium is plus 2 group. Automatically if Ba plus 2 is there, O2 minus 2 is there. Automatically this is a true peroxide. You can say true peroxide. So if for MnO2 it is also like same platinum O2. You will get same like Mn plus 4. If K plus is first group, so oxidation state is here plus O2 minus, that is superoxide. So in out of all options, so that is what BaO2 is the peroxide. BaO2 is the true peroxide, you can say. Question number 72. Already this is the repeated question from the Reamer-Teamer reaction. In previous 2020 paper also they asked what is that among the following which is formed in Reamer-Teamer reaction of phenol. So they ask, simply they are asking the product, right? What is that? If I will take phenol in presence of chloroform and KOH, something like base you can say, so it forms the carbene. Intermediate is a dichlorocarbene. CCl2 you will get. I am not going to write the mechanism, already I done a previous video, you can check it. So this is the OH. So here you will get the aldehyde group. So you can say it is salicylaldehyde. You can say also orthohydroxyacetaldehyde. Salicylaldehyde. Product is what? Salicylaldehyde. Option number 2 is correct. Next, question number 73. What is that? Boron nitride is isoelectronic with. Boron nitride is simply Bn. Bn is isoelectronic with graphite. Boron Bn is isoelectronic with the graphite. Very important and repeated question. So graphite, sometimes they will ask the that is what? Hybridization for graphite is sp2 and for diamond it is sp3. You can read the some differences between the diamond and graphite. Question number 74. Simple question only. What is that? The major product formed in the Chichi-Bavin reaction of pyridine. Simple. Already we know that Chichi-Bavin reaction, right? What is that? Pyridine in presence of sodamide. We can also say that sodium amine. Sodamide in presence of sodamide. So Na plus NH2 minus. This NH2 minus is, so that is going to attack at second place. You will get what? 2-amino. So 2-amino pyridine. This is a very famous named reaction. This is also a repeated question. NH2 minus 2-amino pyridine. So generally it is a NH2 is what? Nucleophilic substitution reaction. Second option is correct. 2-amino pyridine. Question number 75. What is that? Number of signals possible for benzaldehyde in NMR spectroscopy. First you should write the benzaldehyde structure. So then you should find out the how many different types of hydrogens are there. So then because of that we can get the signals of NMR. So I will write this is what? Benzaldehyde. This hydrogen is different, first one. So these for acetaldehyde you will get the other positions. This is one, same positions. So here hydrogen is there, here hydrogen. These two hydrogens are same. So I will take this is the 2, both are 2. Second type. Then this is what meta positions of acetaldehyde. This hydrogen both are same. These are the third type. And this is the para is different type, fourth one. So number of signals is what? 4 types of signals you will get. So very simple question. Based on the protons, based on the non-equivalent protons only we will get the NMR signals. Next, question number 76. What is that? Which of the following element can produce imide with ammonia? So directly you can say whenever lithium is going to react with ammonia, it forms the Li2NH. Li2NH plus H2 gas is released. This is called lithium imide. So answer second one is correct. Next question number 77, right? 77. What is that? The active species of catalyst involved in homogeneous catalytic hydrogenation of olefinase. Homogeneous catalytic hydrogenation of olefinase. So generally they given the options different: nickel, palladium, rhodium plus 3 and rhodium plus 1. So Wilkinson catalyst, already I repeated in previously. What is Wilkinson catalyst? Rhodium PPH3 taken 3 times and Cl. So if you will write the oxidation state, this is neutral 0, this is minus 1 you will get. If you will write x plus 0 minus 1 is equal to power is 0, you will get x is equal to plus 1. So rhodium you will get plus 1. So rhodium plus 1 is a Wilkinson catalyst which converts hydrogen, homogeneous hydrogenation of olefins. So like for example, if olefins is there, CH double bond CH, this is hydrogen, this is hydrogen. So in presence of Wilkinson catalyst, so you will get the alkanes like CH3, CH3. So this is gives means homogeneous attack. Same side, homogeneous attack. Very simple. Directly they asked the metal present in the Wilkinson catalyst. Next question number 78. What is that? The decomposition of H2O2 in endothermic but spontaneous. The driving force of the reaction. If they will ask for entropy, right? If they will ask entropy in spontaneous reaction, entropy is positive, right? Entropy, delta S is positive, and delta S is positive means that is positive entropy change. Positive entropy change. For spontaneous only entropy is positive, the remaining all are negative only. Next question number 79. Which of the following is paramagnetic? So options they given: Cn minus, N2, O2 minus 2, O2. Already I discussed the previous question like this model only. So first you should count the number of electrons. So Cn minus, carbon is 6, nitrogen is 7. 6 plus 7 is 13, minus is 1. So 13 minus 1 is 13, minus is extra 1 electron, 14. Nitrogen is 7, 7, 14 electrons. O2 minus 2 is what? 18 electrons. O2 is what? 16 electrons. So already earlier I discussed less than or equal to 14 electrons is present. It follows the some configuration that I am going to write: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Pi 2py is equal to pi 2pz, sigma 2px, pi star. So like this it is repeat, like pi star 2py is equal to pi star 2pz. So less than or equal to 14. If greater than 14 electrons is present, the configuration is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Next, sigma 2px comes front side, sigma 2px. Next, remaining is as it is. Pi 2py is equal to pi 2pz. Then pi star 2py is equal to pi star 2pz. If I will write like this, then if I fill the 14 electrons in this, 2, 2, 4, 6, 8, 10, 12, 14, right? All are paired, so hence it is a diamagnetic. 14, this 14 is also diamagnetic. Now I will check the 18 electrons. Next, 2, 2, 2, 2. So this is what? 10, 12, 14, 16, 18. So this is also diamagnetic. So remaining is O2. O2 is a paramagnetic. So we should count. We should fill the 14 electrons, right? 16 electrons. 2, 4, 6, 8, 10, 12, 14. So it will not fill directly 2. So whenever it is there like this, it should be shared. Whenever 2 pi's is there, first pi 1, then pi star 2py, then pi star 2pz. So 2, 4, 6, 8, 10, 12, 14, 15, 16. Hence 16 means you will get the unpaired electrons there. Hence it is a paramagnetic nature. Simple concept. Repeated question from this. You can expect this time also. Next question number 80. Direct question. What is that? Joule-Thomson experiment is. Directly we know that Joule-Thomson experiment is what? Isoenthalpic process. Adiabatic and isoenthalpic. Adiabatic and isoenthalpic. So isoenthalpic is delta H is equal to 0. Adiabatic is delta Q is equal to 0. Next question number 81. What is that? Direct question. The oxidation state of iron in amine is directly plus 3. Actually it is exist in iron plus 2 and iron plus 3. So after amine is in like iron plus 3 with photoporphyrin 9 ring, photoporphyrin 11 ring. So that is with nitrogens with 1 chlorine is present. So that is what amine in iron plus 3 form. Next question number 82. This is also direct question. Which of the following gas is not adsorbed on charcoal? Directly answer is helium. This is from the, you can say, surface chemistry. Next question number 83. To estimate potassium ion in gravimetric method, the following reagent used. To estimate what? Generally, if you want to estimate the potassium content, especially in the fertilizers, especially in the fertilizers. In fertilizers, so like NPK is there na, nitrogen, phosphorus and potassium. So for determine the, especially in the fertilizers, for potassium you will use the, that is what, tetraboro. So you can tetraphenyl borate. Like the structure is like this: pH, B, pH, this is also pH, this is pH, tetraphenyl, this is minus charge. So generally it is a, whenever sodium is there, sodium tetraphenyl borate. So simply this is getting replaced by the potassium. Hence the gravimetric and volumetric both methods we will use the, this is tetraphenyl borate as the reagent in the gravimetric, while determine the potassium in the fertilizers especially. Next question number 84. What is that? Which of the following reagent is used to calculate the CC double bonds? So CC double bonds, we will use the ICL as the reagent to calculate the CC double bonds. So this question is from especially from like interhalogen compounds. Next question number is 85. What is that? An organic compound having R configuration, its optical rotation is, we can't say based on the R configuration, S configuration, it is whether it is dextro or levo. Maybe either it is dextro, maybe either it is levo. So generally, so based on R configuration we can't say, hence it is maybe dextro or maybe levo. Dextro means right side, levo means left side. So that is especially plane polarized light, PPL, plane polarized light passed through the compound, hence it rotates left side, it is called levo. If it is rotates right side, it is dextro. Question number 86. Very important. So in P4O10, first you should write the structure. What is the P4O10 means? Before going to write P4O10, you should know the P4O6 structure. What is that? P, here O, this is P, again O, this is P, O, P, this is O. So POP, each POP, next here should be also POP. So this is what P4O6, you can count it 3, 4, 5, 6 oxygens. If you want P4O10, this is the P4O10 structure. What is the question they asked? How many number of POP bonds, right? How many number? You can directly write 1, 2, 3, 4, 5, 6. 6 POP bridge bonds are present. Direct question. Is there any PP bonds? No, it is not any PP bonds. Next, if you wanted to study related to this concept, you can go through P4S3. how many pp bonds, how many ps bonds are there. Next, question number 87, simple and easy concept. Number of modes of vibrations possible for benzene. Benzene structure is like C6H6. It should be like planar, right? Planar. Each is hydrogen, you can expect here. Hydrogen, hydrogen, everywhere hydrogen, right? In among all carbons. In C6H6, generally, so if you want vibrations, two types is there. One is 3n minus 5, one is 3n minus 6. 3n minus 5 is for linear molecules. For 3n minus 6 is non-linear molecules. Non-linear molecules. Generally here, this benzene is a not linear molecule. It is a planar molecule. You should know one statement here. All linear molecules are planar, but all planar molecules are not linear. Like for example, if acetylene is there, like C111CH, this is what linear molecule, and so linear as well as planar. So all linear molecules are planar, but all planar molecules are not linear. This is not linear, hence it is a non-linear. So 3n minus 6. So how many number of atoms are there? 6, 6, 12. 12 atoms. 3 into 12 is 36 minus 6. So you will get the 30. So option number 1 is, fourth one is correct. Based on simple concept only they given the questions. Next, question number 88. Direct question. What is that? C60 fullerene is soluble in the benzene. Direct question, direct answer. No explanation for that. Next, question number 89. What is that? The major product formed from 2,4-dinitrotoluene on treatment with ammonium bisulfide followed by nitrous acid at 0 degrees. So they given the 2,4 first. I am writing the reactant. 2,4, this is the toluene, right? This is the second place. 2,4, fourth place is this one. 2,4-dinitrotoluene. So you can say DNT, dinitrotoluene. Upon reaction with what? On treatment with ammonium bisulfide, NH4HS. This is ammonium bisulfide. So we will get the, in place of NO2, we should write the ammonia amine group. This is, you will get NH2 here. This is CH3. This is NO2. This is followed by nitrous acid at 0 degrees. Nitrous acid at 0 degrees. At 0 degrees. You will get in place of NH2, you will get the OH. Actually, if it is nitrous acid with HCl is there na, so that time you can write the diazonium salts. Nitrous acid plus HCl, you can use the diazonium salts, but only they mentioned the condition nitrous acid. You will get, so phenol. So phenol means you can write 1, 2, 3, 4. So this is 3 place, 4th place, 3 nitro, 4 methyl. So 4 methyl, 3 nitro phenol. You can say 3 nitro, 4 methyl phenol. Next question is number 90. Direct question. The active species involved in the Fenton's reagent. Active reagent involved in the Fenton's reagent is generally FeSO4 plus H2O2. So here Fe plus 2, SO4 minus 2. So upon this you will get the iron plus 3 plus OH minus and plus OH radical you will get. So the active species is iron plus 3. Option number 4 is correct. Next, question number 91. What is that? Which of the following solution has high osmotic pressure, right? So osmotic pressure pi is equal to I into C, pi is equal to ICST. So generally it is depends upon the I means what? Want of factor. We can say in out of all this number of ions which is more, that is the more osmotic pressure. In compared to all, NaCl solution contains a more number of ions in the solution. So hence it is a more osmotic pressure. Option number 1 is correct. Next, question number 92. What are that? Which of the following cycloalkane is relatively more stable, right? So they given the cyclopropane and the cyclopentane, right? Cyclopentane is generally it exists as a envelope structure. So we can write like this is what? Envelope structure. Cyclohexane. Sorry, cyclopentane. Then cyclohexane. Cyclohexane is like this. We will get same like. Generally it exists as a chair form. It is more stable. Then cyclobutane is exists in the butterfly structure. In among all, so as ring size is increases, simply as ring size is increases, stability is increases. So hence more stable is, that is what cyclohexane. Next question number 93. Direct question, simple, from hybridization. The magnetic moment of iron CO5 complex is 0. Already we know that. The hybridization of metal in the complex and shape the complex is iron CO5. Directly they given magnetic moment is 0 means all are paired only. So paired electrons like iron CO5, iron is D6S2. Magnetic moment 0 means it exists as D6S2. So here 8 electrons are present. That 8 electrons I am going to pair because CO is a strong field ligand. 1, 2, 3, 4, 5, 6. So here this is d orbital, this is s orbital, and this is what p orbital. So here 8 electrons, 1, 2, first pairing 1, 2, 3, 4, 5, 6, 7, 8. So remaining is what? 5 CO ligands are there. DsP2, DsP2, 2, 3, 4. Only we will get 4, right? DsP3 should write. 5 are there. 1, 2, 3, 4, 5. DsP3. DsP3 is what? DsP3 hybridization is trigonal bipyramidal. Trigonal bipyramidal. Yeah. So iron structure is like this: CO, CO. This is CO. This is CO. This is CO. So trigonal bipyramidal geometry is DsP3. Answer option number 2 is correct. Very simple concept. This concept I am going to explain in the VBT in next classes. Next question number 94. What is that? In which of the following reaction trans-2-butene is formed? Trans-2-butene is formed means only in liquid ammonia. Hydrogen in liquid ammonia only it forms a trans-2-butene means CH3. Whenever this is there, C double bond C. This is a product. Trans-2-butene. So only hydrogen in liquid ammonia only it forms the trans-2-butene. Remaining like Lindlar's catalyst, Wilkinson and everything. Wilkinson already we discussed. 6 olefins are formed. Like triple bond is there, double bond forms, double bond is there, single bond forms. And CH2 double bond PBH3 is what? Wetting reaction. Next question number 95. What is that? In which of the following molecule participate in electrocyclization? So generally whenever cis double bonds, cis diene is there, if it is a dienophile, you will get, it follows the cyclization. So hence you can say cis dienes are formed cis dienes are, so this is what actually, so this the bonds migrate here, this bond connects, right? So cis dienes are involved in what? Electrocyclization. In out of all options, so only third one is the cis, remaining are trans only. Trans means like this. This is also trans. You can say this is also trans, like this. First one is also trans. Next question number 96. This is from the spectroscopy of UV. Among the given compounds, the compound absorbs longer wavelength radiation from UV visible. Lambda max they asked. So for 135 hexatriene, so you will get approximately 258 nanometers wavelength, and for 1,3-butadiene you will get 217 nanometers. Some table will be there, you can by heart some, so lambda max values. So in out of this options they given, so you will get only hexatriene is the 135 hexatriene contains a more lambda max, longer wavelength. Next question number 97. What is that? According to Langmuir adsorption isotherm. According to Langmuir adsorption isotherm, generally x by m is equal Kp by 1 plus Kp. Kp by 1 plus Kp. So this is what Langmuir adsorption. Langmuir adsorption. So whenever at low pressure you can neglect these terms, you will get only P power 1. So x by m is directly proportional to pressure. So at high pressure the value is equal to Kp only. Kp gets cancelled. You will get x by m is directly proportional to P power 0. Nothing is there. P power 0 means 1. So at low pressure order is 1. At high pressure order is 0. You should remember like this: low, high, high, low order. So generally at low pressure the rate of absorption is linearly proportional to the pressure. At low pressure the option 4 is correct. Linear absorption is linearly proportional to the pressure. Next question number 98. Direct. This is from the metallurgy concept. Which of the following is cementite, right? So directly you can say iron 3 carbide. Iron 3 carbide is the cementite formula. Next question number 99. Among the following, which compound can produce the enolate ion with high rate? So acetaldehyde. Acetaldehyde is CH3 C double bond OH. If you want enolate ion, just you should write 2 here, hydrogen here. So if you will write like this, you will get here, you will get the enolate CH2 double bond COHH. This is the enolate. So enolate is there. Next, second one is acetyl acetone. You should know the acetyl acetone. Acetyl acetone. Acetone is CH3 C double bond O CH3. This is acetone. Acetyl means you should know CH3 acetyl group, CH3 C double bond O. This is going to connect with this. You will get CH2. This is the acetonyl acetone. Sorry, this is what? Fourth one. Acetyl acetone. Next, third one is what? Ethyl acetate. Ethyl acetate is, you can say, right? Acetate is there na. Ethyl acetate. If it is acetic acid, you can say. If it is right, you can write CH3 ethyl acetate. OC2H5. So out of this fourth option, if you observe, there is a 2 possibilities for hydrogen here. Hydrogen here is there. So here you will get the more rate for the formation of enolate. Acetonyl acetone is EAA, you can say. Next, question number 100. Very important. Relatively stable conformer among the following. Only one concept you should remember. If it is a cyclohexane, at equatorial bulky group should be there. At equatorial, if 2 equatorials are more stable, if even though one is at equatorial, one is at bulky, if nothing option is like this, so if option is like this, if accept this option, if option is like this, you can also proceed because this group should be bulkier. So in options they given, so third one is the, first one is what? Tertiary butyl is the axial and that is methyl is the equatorial. Second one is same like tertiary butyl is what? Axial and methyl is also axial, so hence it is unstable. So third one, both are equatorial, and fourth one is axial, one is equatorial. Compared to this, third one is a more stable conformation of cyclohexane. So this is all about the CPGET 2021 question paper. You should practice the questions from different concepts. You will get the marks and you will get the rank. I hope you will get further rank in the universities. All the best for your examinations. If you like my video, subscribe and share to your friends. Thank you very much.